So let's move on and talk about the mathematical definition of the internal forces. And what we develop here is something that is probably not even worthwhile memorizing right away, or don't fool yourself in memorizing it initially. If you taught the class as many times as I did, then you probably will be able to remember what we're going to put here now. But even if we take it as a closed book, closed note exam, I always recommend my students to bring this on a study card so that they can use the study card as a reference to memorize what the positive definition of the internal forces are. So let's go ahead and draw this, and please put it into a study card that you always have handy. So first I'm going to cut here, and I'm going to cut here, and I'm going to call this here the right cut, and I'm going to call this, of course, the left cut. And now I bring in all the positive values. Of course, you may think that you have seen these before, and that's partially true, but sometimes it's not true. Some of the forces that I used were not properly defined positive as they are here now. But I will now use the absolute correct definition in reference to the reference fiber. So the reference fiber defines what is acting positive in which direction. And the first thing I'm going to start with is my vertical forces. So I have a vertical force on this side, and I have a vertical force on this side. I also have horizontal forces, and that applies at both sides. And I have a moment on both sides. This looks like that. Now, on the right side, I have a normal force that points to that side. On the left side, it's pointing in this direction. Then I have a shear force that goes in this direction and a moment that goes in that direction. And don't be confused, it's mostly similar to what I've done before, but now I want to be very clear why it is as it is mathematically defined. So here we have a positive V, here we have a positive N, and we have a positive M. And the same is true here, positive M, positive V, and positive N. And I want you to think about this. The reference fiber here really tells us in which direction the moment is acting and where the left and the right is and so on. And I want you to think about how long this reference fiber is. This element here could really have any length, right? So I could now say that this even has a length of dx. So it's super tiny. It could also be 5 meters. It doesn't really matter. But often later on, we will actually use this in terms of x. And remember something that you have seen in your homework. You may have not known why it was there, but sometimes you've seen that there was an x direction given with that pointing error. Now, why is that important? Because later on, we will express the moment as a function of x, the shear force as a function of x, and the normal as a function of x. So sometimes you would say, like before we said in terms of c, right? Or sometimes, let me erase this here, sometimes you may say, hey, this is equal to x being 5 meters, for example. But really, the way we want to say this is we're going to say that it's just the normal force of x, the shear force of x, and the moment of x. And the same is true here on the other side, depending on which side you cut the system. So this is the shear force of x and the normal force of x. And last but not least, let's understand that this here is the positive side, right? So this is positive, this is negative. Now, why is this important? It is important because later on you may not have the reference fiber on the bottom, or you may not have a horizontal member. So then you need to actually bring this notation here and line it up with your actual problem at hand. So what you should probably do is go ahead and cut a little card out of paper. I, of course, cannot do that, so I'm just going to highlight it here for you. So I'll take this and would technically cut it out. And after I cut it out of paper, what I would do is I would fold it in half right along this line here so that I can use either the left or the right cut and line it up with my problem that I'm currently dealing with. But you will see through application how that becomes beneficial. However, I say it again, in the classroom, I would always encourage my students to bring this card and always have it on them when they solve problems for engineering mechanics. And again, there's no need to convince yourself that you know these definitely from the top of your head. I've seen many students trying to memorize this, and in different scenarios, it goes wrong. So this is a good advice from my point of view to you, that you should always bring this and have this on hand as you solve internal force problems for engineering mechanics. But this now provides all the knowledge we need to actually go ahead and start applying it. Of course, through application, the concept will become more clear. I wouldn't expect anybody to be able to do this right now, how to calculate the normal forces, shear forces, and bending moments. But that's why I will show you on the next pages how to find them for actual number problems. So let's go ahead and start solving our first internal force problem.